We're going to first start by discussing the homework one. So from the first week, we'll just go through each problem so that we understand how to solve it. Maybe some of you solved it, some of you didn't, but regardless, let's just go through each of them, how they can be solved, how to think about them. And after that, we'll get into the lesson. So let's do it. So before I start, does anybody have any questions? All right, I'll start now. Just a moment, let me find the homework that we had. Okay, let's start. So I'll look through the comments every 2 minutes or so. So if you can't speak, you can just write in the chat and I'll see it. Now let's begin. So as you remember, we had some exercises, quite a lot actually. So I did not expect you to finish every single one of them. But yeah, let's just go through each one so that we can figure out how to do them. Some of them are easier, some of them are harder, but we'll just do it all. So you see my screen, right? Yeah, okay, good. Okay, so let's see the first one. So first of all, I mean, clearly each this is each task, and we had the statements, we had inputs, so like what to expect, how many lines and such, and what to do in the output, and constraints just give you like, yeah, in this case, how long the name would be. So the reason why constraints matter is because some solutions would not work if constraints were higher. Like if you're supposed to handle, for example, a billion character long text, then some solutions might just take unreasonably long. We'll get to that later, but for now, yeah, it's just one example. So let's see what the problem was. So here we just ask a person some things and we write them on the screen. So precisely, read your name and the word describing your current mood and print a greeting. So we just write our name and our mood and we say, hello, someone, your brain feels something today. Like if it was Nika and curious, it would be, hello, Nika, your brain feels curious today. So let's see how we would write that. First of all, the first point always, let's just call this homework 1A. I mean, it doesn't really matter, but let's make that. Um, First, we should always start by defining our problem in comments before we go into the code, so that we don't get stuck writing code that we don't understand the purpose of. So what do we want? We want get name and mood, and we just want to print the text. That's pretty much it. So let's break it down. Name, in this case, will be just input, enter your name. So as you remember from previous lectures, input is a function we use so that the user can then interact and write whatever custom texts. And mood is also, yeah, just input. How do you feel? Or whatever. It doesn't really matter what we write here. We did not specify that, so it could be anything. And then what we want. Let's break this down into text that we want to write on the screen. And then later that. So let's see. Text is hello. Let's just copy this for now directly. And let's see. Here we need to insert the name. So one thing we can do is we can do it like this. And this will work because, as you remember, we can add strings to each other to get bigger pieces of text. And this will just become one giant text that says, hello, name, your brain feels this mood today. Let's see how that will work. Let's just run this. This doesn't matter. We can just always run. Let's run this. So we enter our name, like we can say whatever, like Gio. And let's say we feel happy. Hello, Gio, your brain feels happy today. Sorry? Oh, no. Hi. So we were just going through the homeworks. And yeah, that's pretty much it. We just started. So this was the first homework, which was to basically just get the name of user, get the mood, and then just write on the screen, hello, name, your brain feels a mood today. So in this case, we can just rerun it again. We're like Luca sad, and we can see, hello, Luca, your brain feels sad today. So yeah, straightforward. Now we can make this look a little bit better, and what we can do is instead of ending the this parenthesis and then writing a plus and then opening it again and such, there is an easier way to write this, and the easier way is to just write F here and say like this. Well, your brain feels mood today. Let's delete this. So this is another way to write it, and it will be exactly the same thing. So if I can, so look here, it does the exact same job, and it's just a shorter way to write the same thing, and this is called formatting a string. So basically what we did was we had a piece of text, and then we inserted the variables in here that have also text value. So we opened the curly brackets, and inside it we put the variables. Is this clear? So is it clear what we did here, why we broke it down like this? Okay. Okay, let's move on to another homework. And yeah, we'll just go through each of them, and the intuition will start to click for how each one can be thought of and what can be done about it. So first one was just straightforwardly to write it out. Now let's see what's going on here. In the second task, we're tasked to write brain age in seconds. So you're given your age in years, and we assume there's 365 days per year, and we write how many days and how many seconds old you are. But just by the year, we don't care about the days part. So let's see what that means. As input, we only get one number, and that's going to be your age in years. And we have to write how many days old you would be and how many seconds old you would be on your 20th or 10th birthday. So let's see how we would do that. First of all, we would get the age, which would be int input enter your age. Let's just see that that does what we think it does. So like 20 just prints 20. So what am I doing here? I'm taking the input from the user, so just asking them how old you are, like just enter your age. And because input always returns a string, which is text, we write int and put this in here, because otherwise we would get a text and would not be able to do some math operations later on. So what I mean is, if we just wrote it like age equals input like this, then age would be like 20. But now age is 20 and not 20, like this. So the difference is it going to be numeric value or text value? Let's just give it. Yeah, like this. And what we wanted to do is, this is age in years, so let's just say age years. But what we want to calculate is, for example, age in days, right? How would we get how many days old we are if we know how many years old we are? Like what operation would give us that? Like how many days old is a 10-year-old person? Aman, would you like to do this task with me?
Can you repeat the question again one more time, please?
Yeah. So like from here we got that maybe I am 10 years old. So how many days old am I if I'm 10 years old? So like how many days is 10 years? How would we calculate that?
36 seconds, 365 times 10.
Yeah. That's it. That's what I'm asking. So we can say that age I am in years times 365 is how many days old I am. And how would I get how many seconds old I am? How many seconds are in a day, basically? In fact, let's break this down like this. Days in a year are 365. But how many seconds are there in a day? How would we calculate that? Say days in a year. Now we can say here that each day is seconds in a day. How would we calculate how many seconds are in a day, basically?
First, we know that there is 24 hours in a day, and 24 hours times 60 seconds. Yes.
Yeah. So this is 24 hours, 60 minutes, and each minute has 60 seconds. So this
Yes.
is how many seconds there are in a day. And however many days old we are times how many seconds are in a day is how many seconds old we are. And then we can just write on the screen like you are age years old, which is this many days or this many seconds. And like if I say 10 years old, which is 3,650 days or this many seconds. Or if we run it again for like 5-year old, this is how many days and how many seconds year old that would be. So what is the principle of what we did here? We got the input from the user, converted it to a number, because otherwise it would be a piece of text and we would not be able to do this multiplication. We said that there are 365 days in a year. So how many days old you are is how many years old you are times 365. Then we got how many seconds are in a day, which is 24 hours, 60 minutes, each minute 60 seconds. And then we just got how many seconds old you are by multiplying how many days old you are with how many seconds are in a day. Is this clear to everybody?
Yes. I mean,
Yeah. Okay. Yeah. Now let's move on to better tasks. Okay. So let's see task C. A neuron fires if a signal value is greater than or equal to a threshold. Given two numbers, signal and threshold, print fire if signal is above the threshold or else print rest. So this was a bit straightforward use of if. So here's what we mean. So basically, we will give a signal value and we will also give a threshold. And if signal value is less, we say rest, otherwise we say fire. So let's just write it straight up. What that means is that we take two numbers, and if the second one is more, we say fire, otherwise we say rest. That's pretty much the task. So one very important thing is to try to get rid of the terms like neuron and such and just boil it down to a math problem or a computing problem that we can directly solve. So in this case, even though we have a conversation about if is a neuron firing or is it resting, what we're really asking simply is to just write one text if the first number is bigger and write another text if the second number is bigger. So let's just do that. So we have our value of a neuron, which is just int input neuron value, let's say. And let's say we have some threshold. And by the way, threshold is same as like limit or border. So after which point it should change. And let's say threshold. And in this case, our task is quite straightforward. We print fire if signal is more. Okay, let's rename this to signal. Signal. But whatever, I mean, we can call it whatever we want. And in this case, pretty much we are just asked if signal is less than threshold, print rest, else print fire. Also, by the way, if you notice, we can write text like this or like this and they both work just fine. So you can use whichever one you want. It doesn't matter, it can work just fine. Let's see what this looks like. So if we had neuron signal of 47 and threshold 50, it will be resting. But if we have like 20 and threshold is 5, then we are firing. In this case, always remember to check for edge cases, like what happens if they're equal. And if they're equal, they're firing, and in this case, that's exactly what they want from us. But if we wrote it like this instead, we would get that wrong. So just make sure to always check all the edge cases when you're writing some code. And yeah, that's pretty much it. So this was the task. Just take the signal and take the threshold, and if it's less, then print rest, otherwise print fire. All right. Anybody, tell me if I'm going too fast, if you want me to slow down or anything at any point, just interrupt me and tell me that. I'll also check up on the chat every moment. And okay, I'll start moving to the next tasks, which will progressively get slightly more difficult. But yeah, we'll go through it. And by the way, after we finish the lecture, I'll upload all these solutions so you can look at them. Okay. Now task D, signal rate. Given the number of signals recorded and the duration in seconds, print the rate, also signals per second. So in this case, we'll say how many signals we got. That's going to be one number. And the other number is going to be how many seconds that was. So we'll be asked to write and to calculate the signal rate, which is just going to be how many signals per second that was. So just straight up division. So like if we had 12 signals in 3 seconds, that's 4 signals per second. Again, straightforward. Let's write this. Let's say signals were how many signals? And time, let's say, or let's just say seconds. And in this case, I converted to a float, not an int, because maybe it took 3.5 seconds, not just 3 seconds. And in this case, firing rate is simply signals divided by seconds. Because, for example, if 12 signals were in 4 seconds, and we're asked the firing rate, which is how many per second that is, we just have to divide it by how many seconds it was. So this after this, we would say, yeah, firing rate signals per second. So let's just take a couple of looks at what that's like. So if we had like 3 signals in, let's say, 2 seconds, that's 1.5 signals per second. If we had 5 signals in 10 seconds, that's 0.5 signals per second. 20 signals in 4 seconds is 5 signals per second. Or maybe 8 signals in 3.7 seconds would be this many signals per second, 2 point something. So in this case, again, our task was just to take an input, convert it to a number, either int or float based on do we need only whole numbers or also floating numbers, and then just calculate firing rate by saying signals divided by seconds. Then we write it on the screen like this. So the F at the start is what lets us write this firing rate in here. So if we print without the F, here's what we'll get. It will just print firing rate as a text instead of a value. But when I write F in here, it just inserts a value of this variable, in this case, firing rate. So like this, you can see. All right. Aman, would you like to explain this one with me as well? Like to just go through exactly what's going on and why? You're muted if you're speaking.
Can you tell?
Yeah, I can hear you now. Hi, man. Let's go through each line one by one. and we can together figure out whatever might be a blocker or what's going on exactly. How about that? Like, can you first describe like first line?
So in the first line, we are just asking for the user to give input, like how many single signals do we want to receive, and after that, for how many seconds do we want the signal to go on, and then just we calculate the firing rate by signals per second.
Yeah, pretty much. And why do we do int here and float here?
Okay, so we used signals as int because signals is in the integer form, and while seconds can be in the decimal form, so that.
Yeah. That's exactly what I'm asking. Yeah, that's all. Yeah, thanks. Yeah, so to be clear, yeah, that's exactly correct, Aman. So basically, we can only do 4 signals or 5 signals or 6 signals. We can't really emit 3.5 signals. I mean, we have an integer amount of signals, but we might take 3.5 seconds or 2.6 seconds. So that's why seconds is a float, but signals is an int. So this just depends on the task, and it could go either way. All right, thanks, Aman. Now let's move on to the next task. Homework 1E pi. Now let's see what that is. Repeat after me. Let's see. Given a word and a number n, print the word n times, each time prefixed by its index, starting from 1. So we'll get a word, we'll get some number n, and then n times we must write it like this. If we get memory and 3, we must write like 1 memory, 2 memory, 3 memory. So for this one, we would have to use loops. So as you remember, we discussed while loops, and in the second lecture, we discussed the for loops. Well, but this one, let's just do it with while loops, because that's the only thing that we knew at the time. So let's just break this down into steps. So first step would be to get word and n, and second step would be to make the loop, and inside the loop, print. Let's see. What does it mean to get the word in? Yeah, pretty much just input, enter a word, sure, and enter a number, but that seems fine. The autocomplete is a little annoying sometimes because you might get in your way of thinking, but in this case, it's a straightforward task, so it's fine to use it. And by the way, it doesn't matter if you write n like this or like this, but it's generally the case that we use capitals for constants, so like variables that cannot possibly change and will always be the same. Don't even depend on user input or anything. And anything that depends on user input or on the application, we write in smaller letters. Let's see. What exactly do we need? We need to write this word n times. And for each moment, we need to write which turn it is, like 1, 2, 3, and so on. So let's get a variable that will count which turn it is. So let's just say maybe turn equals 1. And what we want to do? We want to print it to the screen n times. So let's just say like this. While turn is less than or equal to n, here's what we could do. We could say, yeah, okay, we could say like that, but actually, yeah, let's do it exactly like that because I want to get us used to this format. So here we can see we would write turn and then word. And after that, we would increase the turn by 1. And let's think about exactly what this means. In fact, let's just first run it to make sure that it works. So let's say I say hello, and I want to write it 4 times. It'll say 1 hello, 2 hello, 3 hello, 4 hello. Now to understand exactly what is going on here, let's go through a debugger. And if you don't remember from a previous lecture, or if you missed one lecture, a debugger is a tool that lets us run our code piece by piece. So right now when I click the run, the entire code is going to run at the same time. Maybe it will ask me for the input here, but then it will just keep running until it goes to the end. A debugger lets us pause the execution of code so that we look at what value each variable has and then continue if we want. Right here in Visual Studio, we have Python debugger, debug Python file, and that's what I'm going to click. Let's give it a second. And let's see what that gives us. So right here, let's then again just say, I don't know, morning and number 3. And now here, we can see right here, all the variables are going to be held. So word equals morning and n equals 3. And nothing else has happened so far because this is where we are. Now, after this line is executed, we see that turn equals 1. Now here we know that turn is 1 and n is 3. So obviously turn is less than or equal to n, so we're going to enter. Now we're going to print turn and word to the screen. So turn is 1, word is 3, so here we see 1 morning. After that we come to this line where we see turn is about to be increased by 1. I run it, and now turn is equal to 2, as you can see here. Now 2 is still less than 3, so we still enter. We write this to the screen again, and then plus equals 1. Plus equals is just a shortcut for increasing a value. So basically in this case, turn will increase again, and now turn is equal to 3. 3 is still less than or equal to 3, so we're still entering. We write it on the screen again, and then turn becomes 4, so now this is no longer true, and we exit. And this is what we get. Is this clear to everybody? All right. Now, I recommend that if any of it is confusing, just rewatch the recording and also look at the solutions again and try to write it on your own. We covered a lot of topics in the first week, but each of them were simple. It's just that there's a lot of them. So it's okay if it takes a moment to click, but it can click. So just give it a chance. Write it again. So our meeting is about to expire, but we will continue on this. Right. So last time we discussed. Last time we discussed this task. So here we get the word from the user. We get a number from the user, so we convert it to an int. Then we get this variable, we call it turn. We can call it whatever we want. We assign it to 1, and as long as it's less than or equal to n, we do these operations. So in Python, when you're inside a loop, to make sure that these operations will happen this many times, while this condition holds, you have to indent them like this. So you can see here the tabs are necessary so that Python knows where that part is and where this code would continue. For example, print done. So this way, Python can know to, let's say, write the word this, execute these parts as long as the loop holds, but then the done part should only be done once. And the way Python can tell that is by the tabs that we put here. So for example, if we put the tab in here, it will write down on each case. So like F3, you can see here down would be written each time. So that's why we need to be more attentive to where we put the tabs in the Python. Most of the cases that if you're writing if or while or something like that, you just have to make sure that you write one tab so that all of its content is inside. And then whatever is outside its content is just going to execute once normally. All right. With that said, let's check out the rest of the homeworks as well. And we can then get rid of it. Let's see. Countable threshold. You'll receive an integer n, then an integer t threshold, followed by n integers. Count how many of those n numbers are strictly greater than t. So this one now is a little bit more complicated, but when we break it down into small steps, it'll not look as scary anymore. So let's first see what that means. So we're going to receive some n, which is going to be a number, some t that is also going to be a number, and then we will also receive n numbers, so like x1, x2, and so on, and xn. And we must say just one number as an answer, which is how many of these numbers are more than t. Our constraints are that we'll have a maximum of 10,000 numbers, and each one will be from -billion to billion. That doesn't really matter here. So like sometimes constraints don't matter at all. Sometimes they matter, so like you have to pay attention to it. So what does that look like? For example, we might say that n is 5, which means I will receive 5 numbers. And the threshold is 50. So we are checking them all against 50. And now these are our 5 numbers. So basically, we are asked how many of these numbers are more than 50. And we can see here 60, 51, and 70 are the only ones. So total of 3 numbers are over 50 in this. So let's see how we would go about that. Homework 1F. Okay. So first we would take N and T. And then for each of the N numbers, what would we do? We would check, get it, and check if it is more than T. And I guess count somehow. Let's figure this out step by step. And I guess afterward we'll just print the result, right? So I'm just writing out the comments so that we have a rough idea of what we're about to do. Let's just take it step by step. So again, let's just go by this example. We'll get an N, which is how many numbers we'll be checking, a T, which is a threshold, so what number we're checking them against, and these are our 5 numbers, for example. So for each of the numbers, we'll check is it more than 50 or not, and if it is, we'll increase some count. So let's say like this. N is int input, the number of inputs, that's fine. T is going to be our threshold, so let's just say int input and enter the threshold. And now we will say that our amount is going to be 0 at first, and in the end, we will print the amount to the screen, right? We already know that. Now let's actually write what we're going to do in here. So here's what they're asking. They want us to take the input n times, and for each time, check what the answer was. So to take an input n times, we have to execute some loop n times. And there are multiple ways we can execute a loop, let's say 5 times or 10 times or 20 times or just generally n times. For now, let's just go with how we would do it in a while loop. There is a shorter way to do it in a for loop, which we'll cover in a bit, but first let's see how we would do it in a while loop. So we would get some kind of index to keep track, like let's just say I equals 0. And as long as I less than n, we will increase I by 1, like this, and then we will do whatever we want. So just this will make it so that this part will execute exactly n times. Because first it's going to be 0, then it's going to be 1, and so on until it's n minus 1. And then when I becomes n, it's not going to come in here anymore. So whatever we write here will execute n times. To check that that's the case, let's see hi in here. Let's just say that n is 3 and threshold is 4. We can see here hi was printed 3 times. And the reason for that is that, yeah, it starts at 0, increases by 1 each time, and as soon as it becomes equal to n, we're going to exit. So yeah, whatever we write here executes n times. Let's do it. What do we want to do for each of the n cases? We want to get the number, check if it's more than our threshold, and if it is, increase some counter that we have. So let's see, let's first get the number. So let's say x equals int input enter number. And then we'll say if x is more than t, we'll just increase the amount by 1. Okay. That's pretty much it. And just to make sure that this works correctly, let's do this. So in fact, let's just go through this exact example. So if we have 5 numbers and our threshold is 50, let's just write each of the numbers. So it's 40, then 60, then 51, then 49, and then 70. And we see that only 3 numbers were more than 3. More than 50. So what did we do here? Let's see. We took the number of inputs that we cared about. We asked for the threshold, so like what number we're supposed to beat. We created a variable that will hold our final answer. We could call it answer or amount or whatever. In this case, I called it amount, but it doesn't matter. You can just call it some whatever you want, even just like O or whatever, but it's always best to name it something that'll be obvious, so that if you look at this code like a year later, you will still understand what this variable is supposed to do, and so that other people can also understand what it's supposed to do. So in this case, our amount is 0 at first, and each time we get a number that is more than t, we increase the amount by 1, and then we print the amount to the screen. So in this case, that was 3. In a different case, we could say that if we have, for example, 4 numbers in the threshold of 20, and they're all bigger than 20, like this, you can see that all 4 of them are bigger, so we get the answer of 4. All right. Do you have questions about this task?
No questions.
Okay. If you get any questions later, don't hesitate to text me. And yeah, I will upload these solutions as well. Now let's do the next one as well. I don't remember how many homeworks we had. Okay, let me just go through them as well, because I think it's really useful to go through them like this, because actually solving problems teaches programming quite a lot more than just explanations of concepts. Like you need both. You need to listen or read an explanation of a concept, then you need to work on problems and struggle them. And then if you didn't solve them yourself, or if you're not sure if that was the best way, you need to see the solutions as well. So yeah, let's just devote some time to this. This is fine. So problem G, climb to target. Let's see what that means. Start from a value start. Repeatedly add step until the value is greater than or equal to our target. Print how many steps it took. So what that means, we have a start, a step, and a target. And yeah, obviously step size is more than 0 and start is less than target. So let's see. For example, we might start at the position 0. We can move by 3 steps on each turn. And yeah, let's say we are standing at 0 meters. We can move 3 meters on each step. And how many steps it will take to cross 10 meters? In this case, the answer is 4 because we are at 0 at first, then we move to 3, then to 6, then to 9, then to 12, and that's when we beat 10. Is the question itself clear here? Like what they want from us, is that clear? Thank you, Cheng. So basically, they will give us where we start, how many meters we move each step, and where we want to reach, and they just ask us how many steps it took to reach there. So here's a simple way we can think about that. First, let's take the start as just, again, int, input, enter. Let's just say start step, which is like this, and target, which is int, input, target. So here we just take the 3 numbers from the user, and now what do we need? How many steps did we take? Let's just say at first we took 0 steps, and while our position, let's say our position at first is equal to start, and as long as our position is less than target, we will increase our position by the step size, and we take an additional step for that. And in the end, we will see how many steps we took. So this is the code that we need. Now let's go through the exact example that they gave us. So we start at 0, we move 3 meters each turn, and we have to move 10 meters. That'll take us 4 steps. Let's put a breakpoint in here just to debug it again so that we can figure out for another case. Let's go through it. So suppose we start at, I don't know, 5, and we move by maybe 6 steps each time. And how long will it take us to reach 24? Let's see what that looks like. So when we reach here, we see that our start is 5, our step is 6. So far we took 0 steps, and our target is 24. So the position at first is equal to 5 because we assigned it to start. And now we come here and 5 is less than 24, so we have to keep moving. So we add a step size to our position. And you can see here position became 11 and we increase the steps. And you see 11 is less than 24, so we continue. We again add the step size to our position and increase our steps count. Now we have taken 2 steps. We're at position 17 and we still have to continue because it's less than 24. We come in here, we are on 23. We come in here again. And just like that, now our position is 29, which is already more than 24, so we don't do it anymore. We come down here and we say we took 4 steps to get from 5 to 24, where each step was 6 meters. Is this understandable? So, for example, if we start at 2, target is at 10, and our step size is 2, we would go step 1, 2 to 4, step 2, 4 to 6, step 3, 6 to 8, and step 4, 8 to 10, and we would arrive there. So in this case as well, it would also take 4 steps. And in fact, let's check that because we don't actually have to think about this like that. We can directly check it as well to confirm that we were correct. Let's just run it. So we would say start is 2, step size is 2, and target is 10. We can see we would take 4 steps. All right. Now let's move on to a different task. Let's see what the next task is. Label the cells. Let's say that cells with even indexes are in group A and cells with odd indexes are in group B. And indices is just plural for index. Given some number n, we would print for each I from 1 to n, group A if it's even and group B if it's odd. So by the way, what does it mean to be even or odd? Even means divisible by 2 and odd means not divisible by 2. And we can check if a number is divisible by 2 simply by checking what its remainder is on 2. And if you remember from first lecture, we can check the remainders by the percent sign. Okay, let's do that homework as well. And by the way, I know it's taken a while for us to go through the homework test, but this is worth it because this is an important part of learning. Let's see. So what they're asking us is to go through numbers from 1 to n. So again, remember, we need to be able to extract just the actual task from the statement, because the statement might be a long story about how some guy is going to a restaurant and has to buy some foods and has to calculate the price, whatever. We don't care about the story itself, we just need the task. So in this case, the task really is to go through numbers from 1 to n, and for each number, if it's even, say group A, and if it's odd, say group B. Like this. Like they will give us 5, for example, and so they give us n. And we say 1 is group B, 2 is group A, 3 is group B, and so on. Let's see how we would do that. First, let's take the n from the user. So again, int input, enter the number of, no, not number of, like enter n, let's just say. And again, what would we do? We would say some I, some variable is equal to 1, and while it's less than or equal to n, here's what we want to do. First, we want to say if I is even, say group A, otherwise say group B, right? That's what they're asking for us. Now, how would we know that it's even? We would know it's even if it's perfectly divisible by 0, I mean by 2, meaning that when we divide it by 2, the remainder is 0. And we check that like this. So if I% 2 is equal to 0, that means it's group A. So let's just say I is group A. And otherwise, we would say that I is group B. And after that, we would increase I by 1. And we can, yeah, that's it. Let's see what that looks like. So for example, when we say 5, oh, I messed up. A moment. So when we say 5, we can see 1 is group B, 2 is group A, 3 is group B, 4 is group A, and so on. So even numbers are in group A and odd numbers are in group B in this case, just like we were asked. So how did we do this again? We asked the user for their input number n, and by the way, small letter n would work just fine. It doesn't really matter. In fact, we can do it. We took some variable I. It starts at 1, and until it's less than, as long as it's less than n, less than or equal to, we check which group it belongs to and write to the screen, and then we increase it by 1. And by the way, there is a way to write this in a syntax that is cleaner, you could say. And here's how we could write it cleaner. Instead of saying it like I equals 1, I is less than or equal to n, and I plus equals 1, I'm going to comment this out. And instead I will do this. Let's say for loop for I in range from 1 to n plus 1. And the rest will be the same. I mean, I can literally just copy this part. Without comments, I mean. Let me just fix this. Yeah, like that. And here's what this will do. This will do the exact same thing. Enter n of like 6. You will just go through them and write them out. Now, why is this the same as this? Because range is a function in Python that pretty much gives us numbers from whatever we start with to whatever we end with. So basically, this is the same as writing start at 1, and as long as you are less than n plus 1, you keep going. So that would mean start at 1 and end at n. And in each case, I would be something. Let's, in fact, debug this so this is more clear. So here we can see n is equal to 5, of course. At first, I is equal to 1, as we can see here. So we say that it's in group B. Then next time we come in, I is equal to 2. Then next time, I is equal to 3, then 4, and then 5. And that's it, we're done. This is the idea of range, and it's mostly useful like this in a for loop, because this lets us go from some starting point to some ending point, and iterate over those numbers and put each value in I. All right, is this clear? Cheng, would you like to explain this one with me? Okay, no worries. Gio, would you mind going through this with me?
Okay. Okay.
Yeah, we can just start from first line and just go through like what each line means. Yeah, pretty much.
So uh, the first line asks the user to enter a number.
Yeah. Yep.
And this input is converted to an integer using this int.
Mm-hmm. Yeah, you're correct. That's it for the first line. And now what's going on like here or here, whichever you prefer.
Uh, there is odd numbers and which are classified as group B, and even numbers are classified as group A.
Yeah, that's correct. And how do we check that? Like, how do we check if a number is even or odd?
Yeah, even numbers with if uh, percentage two.
Yeah, you're right. That's correct. So basically, this would give us a remainder after division of 2, the division by 2, I mean. And so for even number, that'll be 0, and for odd number, that'll be 1. So if the remainder is 0, that means it's even. So that's how we check it. Yeah, that's correct. Yeah, that's pretty much it. And also, can you briefly explain like what is going on in this while loop and what is going on in this for loop? Like these are basically just two different approaches to doing the same thing. But can you briefly explain, for example, how we go through the numbers in the while loop here?
Uh, while loop, it is classifying between even and odd, and for loop, it is creating numbers from 1 to um,
Um, yes, I mean, in the sense that, yeah, the for loop is also classifying the numbers from even to odd. But what I mean is, like, how do we get all the numbers? Like, for example, we take the n is equal to 5, for example. How do we check for first 1, then 2, then 3? I mean, how do we get 1, 2, 3, and so on? I mean, this part and this part, pretty much. I think I confused you. I mean, clearly you understand what I'm talking about. I just confused you, I guess. I apologize. So what I mean was we go through each number and we check if it's even or odd. Yeah, that's true. But how do we go through them? And the way we do that is we say first that I is equal to 1. And then we say that as long as I is less than or equal to n, so like in this case, as long as I is smaller than 5, we will do this and then we will increase I by 1. So that's what we were doing here. That's how we could check for each of the numbers and not just for one number. And then in the for loop, similarly, because of this range thing here, because of this range, we checked for each number because I was first 1, then 2, then 3, then 4, and so on, all the way to the end.
yes.
Yeah. I recommend all of you to rewatch the video just in case if you are confused about any of these points. I'll also share these homeworks. But yeah, that's it. Thanks, Gil, for going through this with me. And now let's see if we had more homeworks in here. No, it looks like we did. Let's see what these ones were. Let's quickly go through them as well. And I guess for today, pretty much we spent our lecture going through homeworks. We had a little bit too much homework. I apologize about that. But I suppose that's fine. I guess the next lecture I'll explain the things that we couldn't do in this lecture. That's all right. Let's see. Brain power. Your brain uses about 20 watts. Given how many minutes you studied today, print the energy in joules. So energy would just be watts times seconds. So given how many minutes we studied today, we pretty much have to figure out how many seconds we studied today and then multiply that by 20 to figure out how many joules of energy we burned. So let's see what that means. Let's see. Homework 1 s1.py. So they tell us brain uses about 20 watts. Let's write that. Brain power, let's say, is 20. Given how many minutes you studied, print the energy in joules. So our input is going to be how many minutes we studied, and our output is going to be in energy. So let's say minutes is input, I mean int input. How many minutes did you study? And then from that, we first had to figure out how many seconds it was. So let's just multiply that by 60. And the energy we used is how many seconds we worked times brain power. And we can just say you used this many joules of energy. Studying, yeah, sure. So in this case, if we run this, say if we studied 4 minutes, we used this many joules of energy. Sorry. If we studied 1 minute, we used this many joules of energy and so on. So let's see what this means precisely. So they told us that brain power is 20 watts. So I just put that in a variable. I mean, a constant, which is why it's uppercase, because brain power is going to be 20 watts, and this is not going to change, at least for this task. And then here we say, how many minutes did you study? And we get that as a number from the user. We convert that into seconds, because we can see here in the task, it says that energy in joules is how many watts of power we were using times how many seconds. So we have to convert this into seconds to get the right value. So we do, we multiply by 60 for that. And then we say our brain power, which is 20, times how many seconds we studied is how much energy we used. So this is much more straightforward than the previous task. But yeah, this is the task. So basically, we got the brain power, we got how many minutes we took, how many seconds that was, converted that into energy, and then we print it to the screen. All right, if you have any questions, obviously stop me at any moment, but I guess I'll continue now just to make sure that we get all the tasks before our time runs out. Let's see what this one was. Reaction time mini-stats. Read an integer n, then read n reaction times. Print their sum, minimum, and maximum without using lists or arrays by keeping running values. Let's see what running value means. So first, we have to read an integer n, and then n reaction times. So reaction time, it just means how many milliseconds it took before you reacted to something, like before you reacted to seeing something or something like that. Reaction times are useful in neuroscience, but right now we can just treat it as a programming task without worrying about what reaction time is. Just know that it's a number. So here, first we take n, which is how many inputs we will have. So let's say how many inputs. And then we can say for I in range n. This is a shorter way of running from, and by the way, this is same as 0 to n. So you can tell that 0 to n is going to be same as n. And in this case, for each occasion, by the way, for I in range n is the exact same as if I were to say some I is equal to 0, while I is less than n, do something and increase I by 1. So this is the exact same as this. Let me just say, these are same. So let's just write it. For I in range n, meaning whatever happens here will happen n times. And we don't even care about the variable I in this case. And here's what we want. Each time we want to get some number, you can say enter reaction time, but obviously it doesn't matter. And then we have to do some things. What things do we have to do? We have to figure out what is the sum of all the numbers, the minimum of all the numbers, and the maximum of all the numbers. And the way we could do that is to keep those values in here. Like, let's say sum is at first 0, minimum is at first some very high number. For example, I don't know, like one, say 1 billion, for example. By the way, it doesn't matter if you use this or not. It's going to be fine either way. I just use them so we can easily tell that this is a billion. Now let's say maximum is at first, I don't know, minus 1 billion, because we're going to have something that's going to be better than that. In this case, we can say 0 because we know our numbers are positive just because of our task. So they're asking us for sum, minimum, and maximum. So we know that whatever value we get, the sum is the sum of them, so we can increase the sum by x. We can also check for the minimum by saying if x is less than whatever the minimum was, the minimum should become the x. And similarly, if x is more than whatever the maximum was so far, the maximum should become the x. And then in the end, we should print each of these. So sum, minimum, and maximum. And to check what this means, let's just quickly go through one small example. Let me just put a debugger in here. And let's say we only have 4 numbers, or even just 3 numbers. Now let's enter our reaction time. So let's say the first number is, I don't know, 100. At this point, sum is 0, minimum is 1 billion, and maximum is 0. You can see here. By the way, do you see this part? Like, I mean, is it clear what's in here? Is it visible? Okay, thank you, Jane. Right, so here we see that so far sum is 0, minimum is this, maximum is this. So we go through each of the variables. We increase the sum by the number. We check that if x is less than minimum, then minimum should be updated to just be x, and it is. And the maximum is also updated to just x in this case. Then we check the next number, which in this case, let's say is 200. So now the sum becomes 300. The minimum is not changed, but the maximum is now 200. And now we come in here again, and let's say now it's 30. So the sum will again increase and become 330. The minimum will become 30 and the maximum will remain. And then we write them to the screen. That's pretty much it. And I guess we don't have time for the last one, but it's all right. You can do it based on this. So we took a lot of time going through homework in this lecture, but I think that's all right. I will upload the solutions, and I encourage you to try to go through them again and maybe rewatch this video. That was it for today's meeting. We'll discuss more